أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. I welcome you all in our today's online session. Hope you all are fine and having good health. We start today's session with the verse of Holy Quran. So last we discussed the concept of probability lecture, and lecture 1 we have discussed that I already shared with you guys. Little bit of review of this question. I will share with you guys. So, in last lecture, I have discussed the concept of probability and statistics. What probability role in the statistical analysis, what probability role in engineering applications and concept scenarios. So, last we discussed the probability statistics play a central role in engineering and technology because they help deal with uncertainty, variability, and data-driven decision-making. In real-world systems, exact values are rarely known, so engineers rely on these tools to analyze, predict, and optimize performance. So this is the clear and concise application as per the definition of probability and the certain further the types of probability and its role in engineering we also discussed in our sessions further. So, in the short term of scenario, the review I am discussing now, further in which probability deal or play a role in different aspect that is dealing with uncertainty, data analysis, decision making, quality control improvement, reliability and risk analysis, signal processing, and communication. These are the roles of probability in engineering as well as in technology. And further, its role in machine learning and artificial intelligence, forecasting and modeling, experimental design, control systems, software engineering applications. So further, these are the aspects in which the probability plays a vital role in engineering as well as in technology. So further, these are the conclusions of probability that play a vital role in different of aspect of engineering, not in engineering technology, but it is also play a vital role in statistical analysis based data driven applications as well as the forecasting, communication, and further the economic levels of financing as well as the probabilistic analysis of data forecasting and the predictions of different aspects, different scenarios, weather aspects, weather prediction, earthquake predictions. We concisely conclude or provide the data, provide the decision, provide the answer on the basis of different data and different aspects of previous deal with these scenarios. So further, we discussed the concept of a coin toss 3 times example. We discussed the concept of a dice throw 1 time. Then these are the 3 parts of that random experiment that what provide the outcomes further form from this given experiments. So if a dice is thrown, then the set of possibilities to throw a dice are 6 possibilities. If you throw a dice, one would become 2 dots, 3 dots, 4, 5, and 6 dot would become appear as an outcome. So this is the sample space of this experiment that the whole scenario, if a dice is thrown, then what will be produced. Coming towards the aspect of part B, that probability of the even outcome. If you throw a dice, then what will be the even outcomes? So that these would be 3 outcomes. 2 would be a pair, 4 would be a pair, and 6 would be a pair. So these are the 3 outcomes. And what will be the three? That if we throw a dice in first outcome, two dots would become. If we throw a dice, it may be that four dots would be occur at the time. If we throw a dice in third time, then six possibility of dot would be appear on that trial of that experiment. So these are the three outcomes in odd scenarios that 2, 4, and 6 would become over there. So how can we find the probability of the event outcome? That by the formula total number of outcome divided by the occurrence of the outcome. That occurrence of outcome are three, in which 2 would become, 4 would become, and 6 would become. So out of 6, 3 divided by 6, we have the probability of odd outcome would be 1 upon 2. As same and certain, if we throw a dice three times, what would be the probability that the odd outcomes would become? So, as per this scenario, odd outcomes, you can see that if we throw a dice, one outcome of dot would be occur, three dot outcome would be occur, or five dot outcomes would be occur. Then what will be happen? Then how can we find the probability? Then 3 divided by 6, and 3 divided by 6 further will be 1 upon 2. So the probability of even outcome is 1 upon 2, and the probability of the odd outcomes is 1 upon 2. So this is conclusion of the final answer, that we need to find the sample space of dice through experiment. Then sample space are 6. That 1, 2, 3, 4, 5, 6 would be a form. Probability of the even outcome, that it would be 1 upon 2 would be form of the probability. Odd outcome of this experiment of dice through example, 1 upon 2 will be the probability. Further, we discuss the concept of define axioms. So further, axioms and rule types of probability we also discussed in previous session, that the axiom of probability, axiom of probability is like our rules and the policy on which the probability of the occurrence would be formed. And that axioms defined by the Andrew Kolmogorov, they form foundation of probability theory. So the probability theory is suggested by Mr. Andrew, and the axioms are further. He suggested that probability that form is non-negative. Probability cannot be negative. It always form, and it always have the possibility of positive. Probability can never be negative as per the axiom number 1. Coming towards the axiom number 2 is normalization. The probability of the entire sample space is 1. So remember this thing. This aspect we already discussed in our previous session, that the probability of the sample space is 1. So P of S, that is sample space. Okay, coming towards the third axiom, that is the additive property. Additivity of the probability is that for mutually exclusive events, the events which are mutually exclusive, they have the probability of the representation would be probability of A union B equal to probability of A plus probability of B. If we have two events, A, and A, three times of A and three times of B, 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 and B. So these are the events which we need to find the probability of these two events. then it will be probability of A union B would be probability of A plus probability of B. So these are the axioms of probability that we discussed over here. So axioms of probability we discussed, and after that rules of probability, that is the second category. As per the rule of probability, rules of probability, that is the additive rule. If A union B, we need to find the two events of probability, then its probability would be probability of A plus probability of B minus probability of A intersection B. Multiplication rule, that for independent events, that if we need to find the probability of A intersection B, that is equal to the probability of A into probability of B over multiply by probability of A condition of B. These are related with the independent events. If the events are dependent, their concept of probability would be probability of A intersection probability equal to probability of A multiplied by probability of B condition with A. So this is the complement rule. Coming over here to the third time, third rule of probability is that if we need to find the probability of A complement, then equal to 1 minus probability of A. This is that how comes the value of probability in the concept of complement rule. This is the third rule of probability. Coming over here, the conditional probability, and conditional probability would be probability of B condition with A equal to probability of A union B into probability of A. So this is the fourth rule of probability. Further, another concept of probability is the types of probability. What will be the classical probability based on the quickly like outcomes, and further the formula. As an example, probability of a favorable outcome, total outcomes. So example, probability of getting here in a fair toss, classical probability in the favorable outcome, that if a fair coin, we need to toss that fair coin and be getting the outcomes. This is the simple experiment of the type of probability we relate to the classical probability. Further, coming to the concept of empirical experiment probability, it is also called the empirical probability or experimental probability, based on the actual experiments on observations. So their concept of the formula of that empirical probability, that probability of A equal to the number of times outcome events occur, total number of tries. For example, if a probability of machine failure based on the past data. So this experimental based formula based probability which we need to find is related to the empirical experimental type of probability. Further, moving towards the concept, the subjective probability based on personal judgment, experiment, or belief. Example, predicting the chance of success of a new project. If we have a project and how much the chance that it would be working and launched successfully. So the number of predicting outcomes we are relating with that experiment of project, that is relevant to the subjective probability. Axiomatic probability, that is based on the rule of Kolmogorov, that based on the mathematical axioms, the three axioms of probability that we discussed in previous aspect, the concept Andrew provide to us. Most general and widely used in modern engineering sciences. So it is the relevance to the axiomatic probability based on the rules that is decided by the mathematician. And these are the three of the axioms. So conclusion of this aspect is axiom provide the foundation of probability theory. Rules help in solving probability problems. Types of probability, that are four type of probability we discussed in this aspect. So coming towards the concept, we explain the random variable probability. That random variables we discussed in our aspect. That random variable is a numerical quantity whose value depends on the outcomes of a random experiment. Instead of describing outcomes in word, we assign numbers to them, making analysis easier. So the definition of this aspect is a random variable is found function that assigns a real number to each outcome in a sample space that is denoted by the x, y, and z. So these are the letters. So if we want to toss a coin, then the outcome would be occur that from the outcome, if we toss a coin, then head outcome would become. And if we toss a coil, then tail cannot be happened. So if the head is occur, then tail cannot be occur. So head is 1 and tail is 0. It is a simple random experiment which by which become the x is a random variable from this experiment. So we discussed the sixth topic of this aspect, and we need to discuss the fifth one as well. But and later on, we will discuss this concept. Coming towards after the definition, the types of random variables are discrete random variables takes the countable value. Finite or infinite values are usually integers. So takes the countable values, finite or infinite values are usually integers. As an example, if the countable values are usually integers, the number of heads is 3 coin toss, and if we toss a coin, that zero no coin outcome would be happen. This is a theory of probability aspect. If we toss a coin, that one head would be formed. If we toss a coin, then two heads would become. If we toss a coin, then three heads would become. So probabilistic analysis, as per the random variable, these are the ways. Number of defective items in a batch. Probability representation, use probability mass function, PMF. So this is the random variable x aspects in which the probability mass function would be formed. It is represented by x. Coming towards the continuous random variable, take uncountable values within a range. Values are real numbers. Example, temperature. So continuous random variable and discrete random variable. This is the main difference between these two things. That if we take an example of a fair coin toss provide the outcomes in the discrete way. That 1, 2, 3, 4, 5. These are, as an example, are the discrete outcome and countable outcome. So these random variables are countable and discrete in aspect. But it coming if we coming toward the concept of continuous random variable, so we take an example of a temperature variation and how it approaches that. If we have the temperature of 25 degrees centigrade, After some time, it would increase 25.5, 25.7, 25.8. So this variation of temperature is not countable. These outcomes, these results are the continuous and variation. These are not countable because as per the decimal places, these value would can be vary. As an example, 25.55, 25.552, 25.5.7, 25.555. So these the infinite outcomes in the continuous way. So these are the continuous random variable which provide the continuous outcome, non-countable outcomes. So that's a reason discrete countable outcomes, discrete variable, and the continuous random variable are uncountable values provide. So probability of representation uses probability density function. So coming towards again to the previous aspect, that is the this would be the comparative analysis between the discrete random variable. So discrete random variable would be countable. Continuous random variable would be uncountable. Discrete random variable would be example provide to the coin toss example, which provide the countable outcome. But if we come towards the temperature example, the temperature variation is a continuous way, so it is uncountable of the example. Discrete random variable have the probability mass function PMF, and the continuous random variable provide the PDF, probability density function. Probability mass function is represented by Px, and the probability density function is represented by f of x. So this is the difference between these aspects. So if there is a question from you guys in the quiz, in final exams, in assignments, that write down the difference between the continuous random variable and discrete random variable and the relevance with PDF and PMF, so you need to provide their answers. So coming toward the probability representation, that is a density function we discussed over here. The important concept of probability distribution, that probability distribution is describe how probabilities are assigned to values of a random variable. So discrete is relevant to the PMF and continuous is related to the PDF. That is probability density function, and discrete is the probability mass function. Coming toward the expected value, that is the mean value. So average value of the random variable is the discrete, that expected value equal to the summation of x into the probability of that random variable, that is p of x. And it is in the concept of continuous aspect summation concept. So in discrete, it is represented by the summation of sigma. But if we coming towards the mean value, and if the scenario is in continuous nature, like example of temperature, so that summation of that function would be conclude or calculate by the sign of integration. Expected value equal to the integration of x, f of x into d of x. So this is the relevance of way that how we find the expected value of continuous and discrete value. So if it's the expected of the outcome is a relevance example of the coin toss example, it is a discrete example, and we find the expected value of this experiment by the summation aspect. But if we have the scenario like dice example, sorry, the dice example is also a discrete example of the random experiment. If we have the scenario of temperature variation, so this is the example of continuous random variable, and expected value would be found from the sign of integration summation methodology. So coming towards another aspect of variance and standard deviation. A measure of the spread of the variability, variance of the value of expected, that how can we find that x minus mu of square, that expected value of the x minus mu square, it equal to the variance of that experiment. And standard deviation, how we can find the square root of variance value we called standard deviation. So this is the main difference between the variance and standard deviation of the expected value, that how can we find over here. Up till now, anyone of you, if have any kind of question, query or difficulty, you may ask in chat box, as well as if you have the query, you may ask in the WhatsApp group. I will answer the kind of question. The GCR or Google Classroom also available for your queries. Please join that Google Classroom and ask if you have the kind of question. I will resolve your queries further. Coming towards the example in engineering, that noise in signal modeling as random variable, software engineering, the number of bugs per module, mechanical engineering example of the random experiments are lifetime of components, that how much time it taking to conclude the component further. Telecommunication, signal and strength in variation. If we receive a signal in the noise and the all the kind of defectiveness, the signal and strength due to this lower of strength would also be cannot form as its originality. Further, coming toward the concept of conclusion, that random variable convert random outcomes into the numerical form, making it easier to analyze uncertainty, model real world systems, perform statistical calculations. They are fundamental in probability statistics as well as in engineering field. So these are the aspects that we discussed. So it's a comparative analysis of PDF and CDF, that how it approaches and how it providing over here. The difference between the PDF and CDF. So PDF we called probability density function, and CDF is the cumulative distribution function. There is a two difference between two things. So coming towards the basic definition of the aspect of PDF and CDF, that defines that according to the PDF aspect, describe a density of probability at a specific value of continuous random variable. That is the PDF. Coming towards the concept of CDF, that cumulative distribution function is describe a cumulative probability up to a given value. So notation of PDF is f of x in a small, and CDF is capital, that is capital F of x, meaning it gives how dense the probability is around a point, and as per the meaning of CDF, that gives total probability that x less than and equal to x. Coming towards the formula, that f of x minus d by dx, capital F of x, and in CDF, that concept f of x minus, we need to integrate from minus infinity to x, f of t dt. Probability at a point that p of x minus equal to 0 for continuous variable. So it's a continuous nature. Probability of x less than or equal to x gives actual probability. As per the graph concept, curve where area under it represents probability, and the CDF, that is non-decreasing curve, always increase from 0 to 1. Range of values, that is that function of x greater than or equal to 0 can greater than 1. So it cannot be less than to 1, less than to 0, it always greater than to 1. But if we coming towards the CDF, it is less than or equal to, greater than or equal to, and less than or equal to 1. So this the concept start from, you can say 0 to 1. In between the curve, we can say it's CDF, and greater than to 0 and greater than 1. This concept is related to the PDF. Total probability area under entire curve equal to 1, and f of infinity equal to the 1. Used to find the probability over interval, and it is used to directly find cumulative probabilities. So these are the basic concepts related to the difference between CDF and PDF and how it approaches the concept to the relevance of in probability. So their key concept with the conclusion be coming towards the aspect that PDF is a derivative of CDF and CDF is the integral of PDF. So these are the two opposite things which are relevant with the integrative aspect and derivative aspect toward the PDF and CDF as well. Simple explanation: PDF, how dense is probability at a point, and CDF is what is the total probability up to this point. So this is a simple explanation of PDF and CDF. Coming toward the conclusion of this topic is PDF gives distribution shape and CDF gives accumulative probability, both closely related and essential in analyzing the continuous random variables. So further, these are the concept of different aspects of probability, types, axiom of rules, and the basic phenomena. So up till now, we end today's session. If you have any kind of question, query, or difficulty, you can type in chat box. My speaker is not working properly, but you may ask your queries in chat box, in WhatsApp group, and as well as in GCRs. The link I already shared with you guys, and in GCR, Google Classroom, I'm share all the kind of recording. I'm share all the kind of lectures, invitation of the classrooms. All things have been share with you guys. Assignment 1, assignment 2 already share with you guys. Quiz 1 I will conduct in inshallah coming of week of Wednesday and Thursday. As per your convenience, you can provide me the time so that I will conduct your quiz in Wednesday or in coming Thursday. So hopefully there is no kind of question at your end. So we are end today's session. Thank you very much.
Thank you, sir.